Good morning. My name is Sharwin Vijayan. My matrix number is CN190254. I'm going to explain and presenting about our project, case 33 project based on dynamic subject. So now I'm going to explain about two energies. One is elastic potential energy, and second is gravitational potential energy. Okay, elastic potential energy is the potential energy is stored as a result of a deformation of an elastic object such as spring, rubber band, and more. It is equals to work done to stretch the spring or rubber band, which depends upon the spring constants as well as the distance stretched. So now I'm going to explain the gravitational potential energy. So the gravitational potential energy is the energy stored in an object as the results of its vertical positions and height. So the energy is stored as the results of gravitational attraction of Earth and for the object.
Hello everyone, my name is Nur Nazifah binti Zulkarmi from Group 8. So today I will like to present about theory and conclusion of case study 3. Theory behind the case study 3 is Hooke's law is a law of physics that states the force need to extend or compress a spring by some distance, which is x, scaled linearly with respect to the distance, which is F equal kx, where k is a constant factor characteristic of the spring, its stiffness, and x is small compared to the total possible deformation of the spring. Then, Hooke's law is only a first-order linear to the real response of spring and other elastic bodies to apply force. The modern theory of elasticity generalized Hooke's law to say that the strain deformation of an elastic object or material is proportional to the stress applied. Hooke's law is only a first-order linear approximation to the real response of spring and other elastic bodies to apply force. On the other hand, Hooke's law is an accurate approximation for most solid bodies as long as the force and deformation are small enough. For this reason, Hooke's law is extensively used in all branches of science and engineering, and it's the foundation of many disciplines. Then, in this general form, Hooke's law makes it possible to deduce the relation between strain and stress for complex objects in terms of intrinsic properties of the material it is made of. For example, one can deduce that a homogeneous rod with uniform cross-section will behave like a simple spring when stretched with a stiffness K directly proportional to its cross-section area and inversely proportional to its length.
Hi, my name is Nur Khalisa binti Jafaris, and I will continue the calculation for this case. So from the data from the experiment, the mass we use is 1 gram equal to 0.001 kilogram, and the length of spring is 7.3 centimeter, and after compress we get 4.5 centimeter. To get x, we minus the length of spring minus the after compress, and we will get 2.8 centimeter equal to 0.028 meter. And for the rubber band, we stretch for 6 centimeter equal to 0.06 meter. And from the experiment, from the video, we get the height for 3 trial. For the spring, 0.55 meter, 0.65 meter, and 0.8 meter. For the rubber band, for the trial 1, 0.6 meter, 0.55 meter, and 0.59 meter. So first we do the calculation for the spring by using the formula 0.5 kx squared equal to mgh. For the first trial, we will get the k1 equal to 13.765 Newton per meter. For trial 2, we will get the k is 16.265 Newton meter. And for the trial 3, we will get 20.02 Newton meter. And for the mass, we times the gravity first, that is 9.81. So the average K, we will plus all the result, K1 plus K2 plus K3 divided by 3. We will get 16.683 Newton per meter. So next, we do calculation for the rubber band. Using the same formula, for the trial 1, we will get K1 equal to 3.27 Newton per meter. For trial 2, we will get K2 equal to 3 Newton per meter. And for trial 3, we will get K3 equal to 3.43 Newton per meter. So the average K plus all the result divided by 3, we will get 3.23 Newton per meter. Thank you.
Lastly is conclusion. In the conclusion, students learn conversion of elastic potential energy to gravitational potential energy, which is 0.5 kx squared equal mgh. Then students are able to understand the given case study and able to come out the information based on their understanding in dynamic concept application. Lastly, students gain more knowledge such as practical and theoretical knowledge. So that's all from us. Thank you.
Okay, that's all from us. Thank you. Bye bye.